and welcome to class. This is Mr. Michael Ezanata. Today we'll be studying the topic trigonometric ratios in our mathematics. It is important that we study this topic because a lot of lessons that we'll be having in future videos will be making a lot of references to the trig ratios. So I believe it will do us a lot of good if we have a firm understanding of what they are. Now, for those of us who are already acquainted with the topic, the importance will not be lost on you because it will still revalidate what you already know and strengthen your knowledge. For those of you who are not yet acquainted with it, this will also do you a lot of good. So let's get down to it. Now we have the basic trigonometric ratios, commonly sine, cosine, and tangent. What is commonly referred to as sine, cos, and tan. Those are our three basic trigonometric ratios, and we want to quickly look at how they can be evaluated, how you can evaluate the sine, the cosine, and the tan using a right-angled triangle. It is also important that you note that they can be evaluated using a right-angled triangle. So let me make a drawing of a right-angled triangle and then we'll see how that works out. Okay, so we have a triangle here. Okay, now this is a right-angled triangle. Let me give it. So we have a right-angled triangle. Let's label it to be A, and here is B with C, and we have an angle here. Let's say we have an angle here. It's called theta. So we have a theta here. Now, how do we evaluate the sine, the cosine, and the tan of this angle theta that we have here? How do we evaluate that? Now, that will lead us to the popular acronym SOHCAHTOA. SOHCAHTOA, that is an acronym that will always help us to remember. SOHCAHTOA. Okay. Let's write very well. Let me write it very well. Okay, so that's SOHCAHTOA. Now the SOHCAHTOA is an acronym. This S there stands for sine, the C stands for cos, and then the T stands for your tan. Alright, now for your O stands for opposite, H for hypotenuse, and A for the adjacent side. It is now left for us to understand how those sides can be gotten for any given time. Now, considering the diagram that we have, the triangle, we have our theta located here. Now, the side that is always across the right angle, this is a right angle here. This is a right angle here. So the side that is always across that, or that is facing the right angle, is always the hypotenuse. In other words, this longest side is the hypotenuse. So it's always the side that is across the right angle that we refer to as the hypotenuse. Now the other two sides, they can change depending on the orientation, depending on where the angle is located. For this particular example, we have an angle at this point. This is our angle here. Therefore, the side of the triangle that is facing the angle is what is referred to as the opposite. In other words, since our angle is here, the side that is facing this angle is this side. Therefore, that side is what will referred to as the opposite side, as the opposite. And of course the remaining side, which is close to the angle, is adjacent. Adjacent means near, so you have the adjacent. So this will be the adjacent side. All right, that is for this triangle. So what we need to understand or remember is that the side that is facing or that is across the right angle is the hypotenuse. Then the side that is facing directly the angle is the opposite, and then the other side is your adjacent. Now if we should also have it, let me make another diagram. Maybe we have the angle here, we have a right angle here. Of course here still remains hypotenuse. Now the side that is facing this angle is this side, all right, and that becomes opposite in this case, while here becomes the adjacent. That is why I said that the adjacent and the opposite side, they can change depending on where the angle is located. So for this example here, for the first example here, we have the angle being at this end, all right, while in the second example we have the angle here, and you can see how the opposite and the adjacent has been interchanged in the two examples. However, your hypotenuse will always remain across the right angle. All right, now having said that, then it's now left for us to go and for us to decipher the formulas for our sine, cosine, and angle. Now using our SOHCAHTOA for the SOH is the, so let me clean up this a bit. Let me clean up here a bit. All right, so for us to evaluate our sine at any given time using this, so whenever I want to evaluate sine theta, the acronym for SOHCAHTOA tells us that sine, which is S, evaluates to the O opposite, the opposite side, over H, the hypotenuse. So this is the sine, the formula for evaluating sine. For you to calculate sine, the opposite side divided by the hypotenuse, that will give you the sine. That will give you the value of the sine of the angle under consideration. All right, let's look at that of cos. Now for cos theta, C for cos is equal to A is the adjacent, so cos theta will be the adjacent side. The adjacent side over H, which is the hypotenuse, over H, which is our hypotenuse. All right, so this is what the in SOHCAHTOA means, that cos theta is equal to the adjacent, A for adjacent, over H for hypotenuse. And the last of it is the tan. Okay, so let's evaluate the tan. So we have tan theta now. We have, let me write that very well. So we have, we have tan theta. Now according to our SOHCAHTOA, the tan theta evaluates to opposite over adjacent. That's a toa. Tan, T for toa, O for opposite, A for adjacent. Therefore tan theta is equal to opposite, the opposite side over the adjacent side. And this is how we can evaluate sine, cosine, and the tangent using the right angle triangle. All right, so let's look at some example of how we can implement this. Now evaluate cos theta, given that sine theta is equal to 8 over 10. But before we even get to this, let's look at some practical examples to drive this point home. All right, let me clean up this side. So now, assuming that we have a triangle, a right angle triangle, labeled as follows, that here is, let me say here is 5, here is 4, and here is 3, and we have our theta to be here. An angle, let's call it theta now. This is an angle. Now, if we want to evaluate our sine theta, for us to evaluate sine theta, what do? We simply apply the formulas. Apply the formulas that we already have for our sine theta, cos theta, and the tan theta. So if we are to evaluate sine theta, so I'm going to clean up all this side for now. So let me clean up all this. All right. Okay. So if we want to evaluate sine theta using this triangle that we have here, want to evaluate sine, cos, and then tan using this. Now for sine theta, remember that our sine theta from the SOHCAHTOA says opposite of hypotenuse. And where is the opposite? Because our angle is here, the opposite is the side which is opposite facing the angle. So the 3 is the opposite over the hypotenuse, which is 5, the side across the right angle. Therefore our sine theta is equal to 3 over 5, which we evaluate to 0.6. Now evaluate 0.6 as our sine theta. Now for the cos theta, our cos according to SOHCAHTOA is adjacent over hypotenuse, and for the particular diagram equation, the adjacent side to this theta here is the side close to it, which is 4. So we have 4 as adjacent over the hypotenuse, which is 5. So we have that cos theta is equal to 4 over 5, which will evaluate to 0.8. Now the last of it, the tan theta. Now tan according to SOHCAHTOA is opposite over adjacent. So, and from the diagram, the opposite of the angle here, this angle, the opposite is 3, while the adjacent is 4. Therefore tan theta will evaluate to the opposite, which is 3 over adjacent 4, and this will give us 0.75 as our value for tan theta. So you see how that works. You see how how they work. So that's how you can evaluate your sine, your cosine, and your tangent of angles using a right angled triangle. Alright, now let's go down and look at the example that I wanted us to look at before now. Okay, we have the question here. Evaluate cos theta given that sine theta is equal to 8 over 10. Evaluate cos theta given that sine theta is equal to 8 over 10. Now questions like this, there are ways that we'll go about them. We are given the value of sine theta and we're asked to evaluate cos theta, or it could be tan theta in some other question. Now it doesn't matter what the trig ratio is. However, we can evaluate whether cos or tan, for equations like this. And how can we do that? The first thing that you want to do is to make a diagram, a right angled triangle. So let's draw a right angled triangle. Now this is the diagram. You might also want to write down your SOHCAHTOA, as that will help you. So let's quickly write that. So the car and the toa. Alright, so we have the SOHCAHTOA. Now you can decide to write your angle anywhere. So let's say that here theta is here. Okay, let me clean that up. So let's say that we have theta to be here. Now considering this triangle, we have the theta here. Using the information provided here, the sine theta is equal to 8/10, and we know that from the SOHCAHTOA, the sine evaluates the opposite over hypotenuse. So when we juxtapose this and this, when we try to compare them, so it means that since sine evaluates the opposite over hypotenuse, and on this side we're having 8/10, therefore 8 stands for the opposite and h stands for the hypotenuse. Therefore we come back to this triangle and effect those values. So if our theta is here and where the sine of this theta, for the sine of this theta to evaluate to 8/10, it means that the opposite of the angle is 8. The opposite of the angle is 8, while the hypotenuse is 10. This is the only way that the given theta here could have evaluated to 8/10. If the opposite side here is 8 and then here is 10, then you can have a sine theta to be 8/10. Now with this in mind, it means that we have to get the value of the adjacent side, which is missing. So we can call that side x. It's missing, we don't know what it is, or let's call it a. So we're looking for the adjacent side now, but you know that this is a right angled triangle, and for every right angled triangle, you can get the value of the missing side using your Pythagoras theorem. The Pythagoras theorem, which states that your c squared is equal to a squared plus b squared, where the c stands for the hypotenuse and the a and b stands for the other two sides. Alright, so when we put this at work, our c squared is hypotenuse, that's 10, so that means that we'll have that 10 squared is equal to the other side. Let's say we're looking for a, so we'll have a squared, which we don't know the value, plus the b in this case is 8 squared. B is 8 squared. Alright, so 10 squared is 100. So 100 is equal to a squared, still remains a squared, we don't know what it is, plus 8 squared is 64. 8 squared has 64. So collecting like terms now, we have that a squared is equal to 100. Now 100 minus 64. Alright, therefore a squared is equal to 100 minus 64, that will give us 36. That gives us 36, and therefore our a is equal, taking the root of both sides, the square root of both sides will give us that a is equal to square root of 36, which will mean that a is equal to 6. The square root of 36, that's 6. Therefore the value of a using Pythagoras theorem is equal to 6, as we have gotten from here. So that a evaluates to 6. Alright, So we'll go back to our triangle. So let me clean up the A that we've been looking for now. So I clean up the A and replace that side with 6. So as we know that here is 6, so we now have a complete right angle triangle having the three sides 8, 10 and 6. Therefore we can go ahead and evaluate the given angle. We have to evaluate cos theta from the equation. Now we should evaluate cos theta, so we'll go ahead and do just that. Now from our SOHCAHTOA cos evaluates to adjacent over hypotenuse. Alright, so if we are to evaluate cos theta given using a given triangle, so it means that cos theta is equal to, now remember that our theta is here. Now where becomes the adjacent of the theta is the 6, the side closest to it, so that'll give us 6 over the hypotenuse, which is still 10. 6 over 10. And that is how we answer questions like this. So what you want to do, you have to make a diagram of a right angle triangle, then try to fix in the values using your knowledge of SOHCAHTOA, and then use your Pythagoras theorem to derive the missing side. Once you have a complete information, you can then go ahead and evaluate others. So assuming that we are also expected to evaluate cos theta for this same triangle, that will simply go ahead. If we were to, tan theta, if we were expected to also evaluate tan theta, we'll go ahead simply and evaluate tan theta. Remember that from our SOHCAHTOA, tan theta evaluates to the opposite over adjacent, and the opposite in this case is 8, while the adjacent is 6. So this is what we would have gotten if we were asked to evaluate tan theta. So you see, questions like this, they are really straightforward if you have a good understanding of your trigonometric ratios. So it is important that we understand this acronym SOHCAHTOA and how we can use it to evaluate our sine, cosine and tangent of angles. Alright, so in the next video we will look at some other things that we need to know about trigonometric ratios. But for now, I want to leave you with an assignment. I want you to study. After having gone through the video, the class video, try to solve the assignment and then submit. And if you have any issue, you let me know. Okay, so let me go down to where I have the assignment now. So this is it here. Given that tan theta is equal to 5 over 12, evaluate sine theta and cos theta. So try this out. Remember how we are to do it. Just follow the class video. Remember how we are to do it. So evaluate sine theta and cos theta, given that tan theta is equal to 5 over 12. Alright, so I'll see you in the next video. Until then, stay safe and bye.